modern automotive safety systems rely heavily on electronics to make it all work. The newer Accelerator system, without any cable linkage, is no exception. This system is generically called drive-by-wire, and it acquires different names depending on the manufacturer. Drive-by-wire integrates an electronically controlled throttle plate with a computer. Features such as cruise control, automatic idle adjustment, and other safety features such as automatic deceleration, if the vehicle goes out of control, are simply added as software additions. This makes it very inexpensive for manufacturers to keep up with newer technologies and features. The accelerator pedal position sensor is of central importance to the drive-by-wire system. This sensor is designed to provide the ECM with accelerator pedal position as well as its rate of change, or how fast the driver is pushing on the gas pedal. Besides providing the ECM with accelerator position, the APP is also associated with other modes of operation. One such mode is the reverse mode, in which the ECM changes the acceleration pattern of the vehicle when backing up, and the selective cylinder kill function, if part of the APP sensor fails. In this last case, the ECM cuts injector pulsation every other engine revolution, in the event of an APP failure. This reduces performance, but allows the driver to reach a repair shop. The APP sensor is a potentiometer, or variable resistor, with a second potentiometer acting as a redundant sensor in case of a failure. Some systems also use a third potentiometer. In other words, the APP is 2 or 3 position sensors in one. The first sensor, sensor 1, is the main input to the ECM for throttle plate control, and the second sensor, sensor 2 or 3, is for redundancy. The ECM is constantly comparing all potentiometer readings against each other. In the event of a discrepancy, the ECM sets a code and goes into a reduced performance mode. The ECM also provides a separate reference voltage and ground to each potentiometer, regardless of whether 2 or 3 pots are used. If the reference voltage or ground is lost to one of the potentiometers, the others are still able to function. This allows the driver to drive the vehicle, with limited performance, to the nearest shop. These series of potentiometers within the APP sensor are also wired differently for redundancy. Understanding the system's wiring pattern is very important for correct diagnosis. A quick look at the wiring diagram will reveal the particulars to the system being worked on. On certain systems, it is common to see one of the APP potentiometers signal increase when pressing on the accelerator, while at the same time the other potentiometer's signal decreases. A throttle control actuator is also employed in drive-by-wire systems to do the actual throttle opening. The ECM responds to the APP signal changes by opening the throttle plate. Some systems also use a separate throttle control computer or throttle control module. The throttle control module, if separate, will always work in conjunction with the engine control module in order to control the vehicle's acceleration. Both modules communicate with each other via a serial data line. As the APP signal changes, the ECM commands the throttle actuator motor to open the throttle plates a certain amount. The throttle actuator assembly and TPS sensors then relay the throttle opening back to the module. The APP signal is constantly being compared to the throttle actuator assembly position sensors. Any discrepancy between the APP and the TPS sensors will set a code, with the system also going into limp-in mode. The ECM flags a discrepancy when the deviation or difference between the APP and the TPS signal goes above a maximum pre-programmed amount. All drive-by-wire systems use dual or triple TPS sensors. Again, this is all done for redundancy. Dirt and carbon deposits in the throttle plates have a negative effect on throttle control. The ACM will always try to adjust or compensate for the air restriction in the throttle body. This excessive throttle opening creates the APP to TPS signal discrepancy, triggering the ECM into setting a code.